Washington State University. Go Cougs!
The next step is to use this trie that we have created to perform sequence prediction, or in our case, prediction of the next activity. Note that we could go back to the original set of symbols or observed activities and count all the times that a particular activity occurred in different contexts and use that to determine the probability that it will occur next. But that would require us actually storing every activity that's ever been observed and go through them all to do these tabulations, and that would be very expensive in terms of storage time and computation time. So this trie allows us to compress a lot of the information, thus making storage much smaller and the counting of frequencies for probability calculation much simpler. In order to determine what activity is likely to occur next, we'll consider every possible activity and individually determine the probabilities that that activity is the one to occur next, ultimately deciding that the one with the highest probability is the most likely one to occur next. So let's work through an example in which we're answering the question, what is the probability that the next symbol in this sequence, or the next activity in our sequence, is A? Given the trie that we learned, this will involve a few steps. First of all, let's consider the probability that A is the next symbol to occur for all the different phrase sizes that we're storing in our tree. Remember, all of these nodes at the first level represent phrases of size 1, one symbol long. All the nodes at the second level represent phrases of size 2 or length 2, and at the third level represent phrases of length 3. If we consider all these phrase sizes, or what is typically referred to as an order, we can consider the probability of the next symbol being an A. Order 0, or length 0, or this first level in the tree, we have 5 plus 9 plus 1 plus 2, or 12 possibilities, 12 phrases of size 1 that we have seen. And of those 12, 5 of them have been A's. So if we're considering a phrase of length 1 symbol, the probability that would be an A is 5 out of 12. Now when we look at phrases of length 2, we have to consider the fact that given this input sequence, we're trying to determine the probability that the next symbol is A. So for a phrase of length 2, we have to consider the context, which would mean we're not just looking for a symbol of A, but we're looking for a symbol of A given that the previous symbol was also A. So what's the probability that a phrase of length 2 would be A? So in our tree, all phrases of length 2 where the previous symbol was A are indicated right in this part of the tree. We have two possibilities, AA and AB. So we have 5 total possibilities for a phrase of length 2. It could be either AA, AB, or A followed by empty string, meaning that there was no phrase of length 2, only those of length 1. So out of the 5 possibilities, 2 of them are A followed by A. Similarly, if we were going to consider a phrase of length 3, we would be looking at what's the probability that the next symbol is A given that the previous 2 were AA, or a phrase AAA. And for all of the possibilities, we have AAA or AA followed by empty string. So of the 2 possibilities, one of them is the phrase AAA. So the probability, if we're looking at phrases of length 3, is 1/2. Secondly, for each one of these different phrase sizes, we have to consider what is the probability that the phrase size is that length versus a phrase size that is a shorter length. So for every phrase, we have to consider the probability that the parsing does what we call escaping to a lower order or shorter phrase length, and that is the frequency of the phrase ending at that point. If we are parsing this input string and trying to determine what is the probability that the next symbol is an A, and we're currently at order 1 or at this level of the tree, and we're trying to determine what is the probability that the phrase is not this long, but is actually a shorter phrase, we can look at the fact that the shorter phrase occurred 5 times and the longer phrases occurred 4 times. So the probability that the phrase ends with just one symbol and doesn't come to this level of the tree is 1 out of 5. Similarly, if we are at order 2, we're looking at the context, we've already observed AA so far. We're right here in the tree, and we're trying to determine what is the probability that the phrase is not this long. It's not 3 symbols long, but should stop with 2 symbols. Well, we've seen the 2 symbol phrase twice, and we've seen the 3 symbol phrase 1 time. So the probability that this should be an empty string and should escape back to this previous order or previous level is 1 out of 2. So we're going to combine or blend these probabilities. We're going to combine the probability that we have a phrase of length 3 with the probability that that third symbol is A. Then we're going to look at the probability that it's only a phrase of length 2 and the probability that that second symbol is A. And then the probability that it's only a phrase of length 1 combined with the probability that that one symbol is A. Therefore, in order to determine the probability that the next symbol is A, we need to compute a blended probability that considers the probability of each context size or phrase size with the probability that given that context size or phrase size, A is the symbol that's going to occur next. So we will look at all 3 phrase sizes in our example try. We'll look, this value is going to represent the probability if we're looking at a phrase 3 of length 3, then we'll look at the probability of an A if we're looking at a phrase of length 2, and finally a probability if we're looking at a phrase of length 1 or a single symbol. So if we're looking at a phrase of length 3, then we're already have seen an AA, we're determining the probability that the next symbol is also an A. So combined phrase of A, A, A. In our try, that would be this node right here, corresponding to the path A, A, A. And we've already calculated the probability, if we've already seen AA so far, that the next symbol being also an A would be 1/2. So this is the value that we fill in for the probability that the next symbol is an A if the phrase really is of length 3. Now we're going to determine what is the probability if it's not a phrase of length 3. So first we need to calculate what is the probability that it is not a phrase of length 3 or that we escape to the previous order in the try. We calculated that here. If the context was AA, the probability that we escape to a shorter phrase or the previous order is 1/2. So we look at the probability of 1/2 that it is not a phrase of length 3, then the probability of all the remaining phrase sizes. So if it is a phrase of length 2, then the previous symbol is just A, combined with our hoped next symbol, the combined phrase is AA. In our try, that would put us at this node right here. And if we've already seen an A, the probability that the next symbol is also an A was computed over here as 2/5. So 2/5, and then finally, what is the probability that it is not even a phrase of length 2, it is only a phrase of length 1, combined with the probability that that phrase of length 1 is a single symbol A. So if we've already seen an A, then the probability that it's not a phrase of length 2, but we stop with that individual symbol has already been computed over here as 1/5. So the probability that it's not even a phrase of length 2 is 1/5, and if it's not a phrase of length 2, then it's a single symbol, and all the single symbol phrases that we have seen are these here, and we've determined that the probability that that single symbol phrase is an A is 5/12. So the probability that it is going to be an A that we observe next in our sequence of symbols or activities or whatever we're trying to predict is 1/2, for a phrase of length 3, plus 1/2 times the quantity 2/5 for a phrase of length 2, plus 1/5 times the quantity 5/12 for a phrase of length 1, or a probability of 0.74 that A is the symbol we're going to observe next. Now, if we want to answer the question, what is the precise symbol or activity that we're going to see next, we will have to calculate that probability for all possible symbols. So here we're answering the question, what is the most likely next symbol? We already know the probability given what we've observed so far and stored in this trie. The probability of the next symbol being A is 0.74. So we repeat these calculations for B. Again, we're based on the context that we've already seen this sequence. So if we're looking at phrases of length 3, which is the largest phrase that we see in this trie, and we're considering the next symbol being a B, then the phrase would be AAB. AAB does not occur in this trie. So if we're looking at phrases of length 3, the probability would be 0 out of 5. But then we can also consider phrases of length 2 and length 1. The probability that we escape to a phrase of length 2 is 1/2. And at this level, the probability that the next symbol is a B corresponds to the phrase AB, because we've seen an A and we're looking for a B next. That probability that the next symbol is a B is, as we can see, 2 out of 5, which we fill in here. We already know the probability of escaping to the previous order or shorter phrase length is 1/5, but at that level, the probability that that single symbol is B is 4 out of 12, for a combined probability of 0.23. If we repeat this process for C, we get a probability of 0.01 that C is going to be our next symbol in the sequence, and a probability of 0.02 that D is the next symbol we're going to see in the sequence. So by an overwhelming majority, the probability of A being the next symbol is 0.74, so the most likely next symbol is A. Then you can see how, given a history of activities that we've observed and labeled with activity recognition, we can predict which activity is going to occur next and prepare for it with our analysis or our context-aware service.